So one box is being pulled by a force of 50 newtons at an angle of 25 degrees to the surface. If the second box mass is 10 kilograms, determine the acceleration of the system and the tension of the string. So it wants acceleration and tension. Those are the two things we are finding. So what's A and what is capital T? So what was my first tip? Most force questions, you want to draw a diagram. So we've got a box connected to a box by a string on a flat surface, and one box with a mass of 20 kilograms is being pulled by a force at an angle of 25 degrees to the surface. Now this is tech active because the angle is 25 degrees. How could we change it to tech free? The angle could be 30 degrees or it could be 60 degrees. All right, if the second box's mass is 10 kilograms, determine the acceleration of the system. So there's a tension between the two boxes, so the arrow direction is important. So in a connected system, you need to look at each mass separately. So let's look at this mass. What is the force sum in the x direction? What is the force sum? The tension, so the tension equals MA, and the mass is? So mass times acceleration, Newton's second law. Okay, so that's our first equation. So most of these questions you're going to do simultaneous equations. All right, now we look at the second mass. Second mass, let's do another equation. Let's again go in the x direction. So if we sum the forces, 50 cos 25 degrees, so that's going that direction. Yep, we're splitting this force into the x component, very good. So it's positive, and then we are minusing t, and that equals the resultant force, which is the mass times the acceleration. Okay? So we've got two equations. We need to sub 1 into 2. So T equals 10A, so let's sub that in. We're trying to find A, so we're going to rearrange to get A by itself. So bring this over. 50 cos 25 degrees equals 30A. A equals 50 over 30 cos 25. Type that into your calculator. Approximately 1.5105 meters per second squared. Let's find the tension. We can just sub it back into equation 1. T G equals 10 times that answer we just got. Ah, really? Okay. So the tension force between the two boxes on the string is 15.0105 approximately. Newtons.